Find the sum of the first 17 terms given this rule. Now, once you see this rule, you should know it's arithmetic. So we're trying the rule for an arithmetic series. The rule for an arithmetic series is n divided by 2 times a1 plus an. N is the number of terms. A1 is the first term. An is the last term. So, to do this, we now need to find those three variables. Well, n is pretty simple. The number of terms, 17. If I want to find a1, or the first term, you take the rule and plug in what? 1. If I want the first term, I plug in 1, and when you get that, you get 3 times 1 is 3, so that becomes negative 1. So the first term is negative 1. The last term is actually the 17th term, since there's 17 terms. So that's going to be 2 minus 3 times what goes in there? Well, won't that be 17? Which is 2 minus 51, which is negative 49. Now let's think logically for a second before we go any farther. If I'm doing 17 terms, look at this rule. I'm minusing 3 each time, and my 0 term is 2. Is it likely that my first term is a negative, a small, and then as I keep decreasing, will my last term be a negative as well because I keep shrinking? So we can always look at a rule to make sure our data makes sense. And it does. So let's sum this. So S17 is going to be the number of terms divided by 2 times the first term plus the last term. So this right here gives us what, negative 50? So you got 7 over 2 times negative 50. Can I put that over 1? This makes it a little bit easier for some people. Because watch right here. Is it easier to cancel the 2 with the 50 than the 2 with the 17? So won't that give me what, negative 25? So I now have S17 is equal to 17 times negative 25, which looks like, if I have 17 quarters, don't I have negative 425? Negative 425. So for this particular problem, you need 3 things, and it took you a little bit to get the pieces you wanted. But you're given the rule, which helps a lot. Number 2, we have a geometric series, and we know our fourth term is, we know we're going 4 terms. Now for a geometric series, here's the formula. The sum of them is a1 times 1 minus r to the nth over 1 minus r. So which term are we actually basically missing? We got everything but one term. We have a1, we have r. What do we need? Do we need n? So what's n? Well, didn't we say fourth term? So it's 4. So this one's actually pathetically easy, kind of, because we have all the information. It's just the number crunching which is going to be annoying. So S4 is going to be what? A0 is 2. 1 minus r is 3. N is 4 over 1 minus r. So the sum of the first 4 is going to be 2 times 1. What's 3 to the 4th is 81. And 1 minus 3 is negative 2. So what do we got here? Don't these things cancel right here? Leaving you negative 1 on the bottom? So doesn't that leave us what? Negative 80 divided by negative 1, which is 80. Now let's say you missed a negative, and somehow your answer became negative 80. Look at the original. Does it make sense that could be a negative 80? If you start with 2 and you're multiplying by 3 each time, where the heck are you getting a negative from? So if you miss, just be careful. Always look at your answer to make sure it makes kind of sense. The last one is an infinite geometric series. The formula is as follows. S infinity is simply A1 over 1 minus R. Look at this formula. Basically the same thing, it's just this right here became 1 and disappeared. Now, what's the stipulation on this one before we go any farther? Doesn't R have to be less than 1? A decay? Is this a decay? Yes. So we're okay. You first have to check that, or else you cannot do it.
So this is not a decay?
R has to be less than 1 to do this. So for this formula, A1 is 5. R is 1/3. Now you just got to do the math. And to do this math, don't we have to, in order to subtract these, what do I change 1 into? You need to change it to 3 over 3. So you have the same bottoms. So S infinity is equal to 5 over, what 3 minus 1 is? 2/3. Now for some of you, most of you would probably struggle if I try to do that. So I'm going to rewrite this as 5 divided by 2/3. Isn't that 5 divided by 2/3? Hopefully. You can see that. And when you divide, can I change that to 5 times and flip this? Can I put a 1 right here? So would that be what? 15 over 2? Which is 7.5? Which this is actually fine. So if I wanted to add up an infinite amount of terms, it's 15 over 2. Here I wanted to add 4 terms, given this information. It was 80. Here I wanted to add 17 terms of an arithmetic sequence. There's my answer.